Hi everyone, thank you for coming. Before I start, I'm going to ask you to raise a few hands. Who here is programming in JavaScript on a regular basis? Okay, so about 70%, more than half. Who's ever practiced domain-driven design? So, hey, something like 10, 20%. Okay. So as Vladimir told you, I've been in the software development world for about 10 years now. Where I work mainly on customer-facing products. So I build video games. I've made mobile applications, web applications. Right now, I'm working at Inato. So we are helping pharmaceutical companies bring new drugs to the market faster. Hope it was clear before. We are using JavaScript a lot. Our product basically is a data pipeline written in Python and a web application written in JavaScript. So we are happily using JavaScript both on the back end and the front end. And this talk is going to be an experience report of our journey using domain-driven design to fight the problems we have with JavaScript. Okay, so I have only 2 hands and I have 3 things to do with my hands. Passing slides and turning pages. Hope it's gonna work out. So before I dive into the solution space where domain-driven design belongs, I'm going to focus a bit on the problem space. When you work as a team on a business-oriented software, like I did, on non-trivial projects, so projects that last more than a few months, specific issues arise. Even though I've used the expression JavaScript fatigue, I think JavaScript fatigue is only a consequence of a more deeper issue, which is software rot. So software rot can take several forms. I'll try to illustrate a few of them. Let's try this. Okay, so first, there is this kind of natural phenomenon, some kind of erosion of your technical stack relevancy over time. Everything you use, language, libraries, frameworks, databases, every tool is getting older every day, just like you. And this is particularly intense in the JavaScript world, JavaScript ecosystem. So it does not matter how state-of-the-art your stack is right now. In a few months, if you're lucky in a few years, it will be out of fashion. So obviously this chart is completely made up. The curve is not exactly like this. There's no unit, but you get my point. Things will erode. So I'm not saying that you should follow every trend, try every JavaScript library that comes out every day. GitHub stars-driven development is not what I recommend. But on the other hand, if you stay too far behind the technology wave, if you wait too long, you can get stuck. Two reasons why you get stuck. Maybe this new library you want to use is not compatible with your framework version. Or maybe you want to use this new tool that everyone's talking about, but for that you need to upgrade your Babel version. So yeah, you can get stuck. Yeah, doesn't look great, but I've taken these numbers from the State of JS websites. They come from a survey where several thousand developers answered about the JavaScript technologies they are using right now and the one they want to use or want to learn. Red basically means I'm using it, and blue means I want to use it or want to learn more. And you can see that for the past 2 years, React has been the default choice. More than 50% of answers say I use it right now. So it's kind of a safe choice. But you can also see that Vue is growing really fast, and that Preact is becoming a thing. So even though React is a great choice right now and has been, it might not be long before a replacement comes out and takes over. For instance, nobody wants to hear about Backbone anymore, but it was like really hot back in the day. Nasty side effect is that the more deprecated your technical stack is, the harder it is to hire developers. Nobody wants to work on Backbone or Angular 1 right now. So the more deprecated your stack is, the harder it is to hire. So you have less time to upgrade your technical stack. And this creates quickly a vicious cycle where you're stuck in the past. Okay, so this was mainly about like rendering technologies, React, Vue, that stuff. But when you need to fetch and manipulate data, you have a lot of choice also on the front end. A few years ago, having a REST API and storing the result in your Redux store was the default choice. But you can see that GraphQL is becoming more and more popular. So projects like Apollo and Relay make it easy to integrate GraphQL in your React app. So maybe the days of REST APIs are over. On more personal note, we're using Relay Modern at Inato, and I find it really awesome. So yeah, even though you spent all this time, all this effort trying to learn about Redux, magic, reducers, actions, it might be time now to start looking around for its replacement. Okay. Another way to visualize the fact that over time your software is rotting, your code base is decaying, is this other made-up chart of the average of experience of your team over your code base. So this happens naturally, even if you're the only developer on one small project. Given enough time, you will just forget about how things work. The code you wrote 6 months ago, when you read it again, it might as well have been another developer who wrote it. You don't remember anything. If you're growing, if you're hiring software engineers, like we are right now, every new software engineer joining the team contributes to lowering this familiarity, this average familiarity of your team over the code base. Of course, you will train this person and he will get better over time. But every time someone new comes in, you take a hit. But even when your team's not growing, even if your team stays the same, your code base is growing. Every new commit, every new pull requests makes the number of lines of code grow naturally every day. It's not that your software is doing more complicated things. It's not that you're implementing this algorithm in a different way. Generally, it's more that your software is doing more things. Features are adding up. I don't know if you've read this article by Intercom on their blog that says product strategy means saying no. But no matter how skilled your product team is, they're going to ask for more features. They're going to ask you to do more things for it, ask your project to handle more use cases. And these additional use cases are going to mean more code, which means in the end, you'll get less familiar with the amount of code in your code base. It's a bit like the second principle of thermodynamics. There is a natural software entropy. This is the evolution over 10 years of the number of lines of code in Android core package class, Activity Manager Service. So it went from about 10,000 lines of code 10 years ago, and it's now over 30,000 lines of code. So it's the blue chart. The red chart is the compound annual growth rate of 10%. And you can see that they kind of follow each other. So maybe the name Activity Manager Service shows that this class has a scope that's too big, and that's the reason why it's growing like this. But even if you choose your name carefully, it's going to happen to your code too. Okay. So another thing that that's hurting your familiarity with the code base is iterative development. Whatever your flavor of Scrum, whether you're doing Kanban or whatever, if you're using an iterative development process, it means that requirements will change over time. And changing requirements, even if you add no new features, they mean that your code is changing, and it means that you become less familiar with it over time. So in the end, this is, according to me, the natural evolution of the performance of an engineering team over time. At first, everything's perfect, everything's new, you're going fast, you have no bugs, probably because you have no users. But yeah, it's perfect still. And as time goes by, as complexity adds up, your ability to create value goes down, and your number of bugs goes up. So new frameworks, library updates, new team members, changing features, new features, everything contributes to lowering your velocity and increasing the amount of defects in your software. Okay. Usually when things go bad, when you're having too many bugs and when you can't move fast enough, someone starts getting up and says, hey, let's rewrite the whole thing, you know? Let's start again. We'll choose a new framework, new libraries. We'll have no more bugs. We can do it all over again. And at first, it feels great. It's a great idea. But quickly, you end up in the same situation that you were before. You didn't fix any of the root causes, so you've just delayed the inevitable. You are like spinning your wheels, but in the end, you're not creating value for your customers. You're just rewriting your front end. Another popular solution when doing a rewrite is to move along, get on the microservices train. And microservices are often discussed along with domain-driven design. I'm not saying that microservices is a bad idea. I even think it's a good one. For instance, if you have a modular microservice architecture and you have to rewrite something, instead of having one big rewrite to do, you can do one smaller rewrite, and you can do it independently of other rewrites. So it can work, but microservices also come with their own challenges. I have two examples of this dark side of microservices. First example, monitoring. Even though every microservice is doing okay, your whole system might not. It's the same thing with unit tests. you may have your whole unit test suite green. That's not good enough. Maybe your application's not working. Second thing that's harder with microservices is debugging. If you have to debug something where the root cause is eventual consistency, good luck. Good luck with that. So you can try it. You can try rewriting your whole code base with microservices, but be ready to face other kinds of problems with this technique. My suggestion is to do like me, to start with domain-driven design. So domain-driven design, it's at first a book by Eric Evans, domain-driven design, tackling complexity in the heart of software. And I can read you the Wikipedia definition. Domain-driven design is an approach to software development for complex needs by connecting the implementation to an evolving model. So I still don't really understand this definition, but with practice, I've come up with a different one, my own definition, and it's the following. Your domain, your business rules, your business concepts and rules are already complex. You're doing something that's complex, otherwise someone else would have done it. So just two things, one thing you want to do, one thing you don't want to do. The thing you want to do is to make sure that your engineering team and your product team have a common, precise language to talk about business concepts. Evans calls it a ubiquitous language. You want to have a clear terminology, use it everywhere, from specification documents to the code. That's the thing you want to do. The thing you don't want to do is to mix with your already complex domain-related code additional complexity coming from technical specificities. So which database are you using? Which framework version are you using? So your domain code should be like a holy sanctuary where no technical consideration are allowed. So to dive into this ubiquitous language thing, so that's the thing you want to do. You want to create, share, and enforce the use of specific terms for all your business concept. A good starting point, at least the one we took, was the names we already had in our code. Most likely you have names, you're using names, you have classes, you have at least variable names. But chances are the names you're using in your code are not the same as the names used by your product team. So first, make sure you're sharing these names. The thing we did was just write down the names we were using in the code on giant sheets of paper, put them on the wall, and we started using them in our discussions with the product team. So whenever we stumbled upon a term where product team was saying client and we were saying user, we had to change this. Generally, we try to use a product team term. So if they say client, this is a client. It's not a user. At Inato, in our product, we're trying to model patient recruitment over time. So you can see on the right, there's a clinical trial going on, and we are trying to recruit patients to test our drugs on. So you can imagine we're manipulating several different notions of patients over time, patients per month, patients per year, average patients per month, maximum patients over 3 months. So all these notions that look similar but are different, and we didn't have clear names for all these concepts. At some point, we realized that we only had two notions: the notion of average patients per month and maximum patients per month. The actual unit of times per month or per year was not important, but the fact that it was either a maximum amount or average amount was tremendously important, was a huge source of bugs. So we settled down on these two terms. We wrote them on the walls. We wrote them in our GitHub issues, Trello cards, everything where we write things down. We are using those terms in Slack in our oral discussions, and the most important thing is we are using these exact terms in our code. So right now we have this kind of ubiquitous language police where whenever someone's not using the official term average patient flow, someone has to come and slap him. So let's get a bit technical right now. Once you found good names for your domain concepts, so we have found this average patient flow. This is an important concept for us. You can start modeling them using value objects. A value object is simply an immutable object that encapsulates one, but maybe several attributes related to a business concept. Here, for instance, we have our average patient flow wrapping a single number value, patients per year. But we know this is average. This is not the maximum. And we cannot mix it up in our computations. So we have this ubiquitous language police. We also have like primitive data types police in the code base. We're not allowed to use primitive data types like numbers to make patients recruitment computations. We have to use this value object, otherwise it doesn't work. So this is not 100% JavaScript. There are a few flow annotations. We're using flow, which is a static type checker, similar to the way TypeScript works, for instance. And honestly, without a static type system, value objects and the whole domain-driven design thing starts to lose a lot of value. So if you're working with JavaScript and you're not using Flow or TypeScript, I think you're leaving a lot of money on the table. Okay, so we've done this ubiquitous language thing. We've settled down on common terms with our product team. That was the thing we had to do. Now the thing we don't want to do is to add technical specificities to our domain-related code. So how do we do that? How do we achieve separation of concerns? We did that using this architecture, layered architecture. So at Inato we have 4 layers. I'm going to talk about them starting with the domain layer. So the domain layer here corresponds to the circle inside on the left. The important thing is that it depends on no other layer. It's every other layer depends on it, and it's the heart of your software. It's where your business rule, business objects, domain concepts, everything lives inside your domain layer, and it depends on nothing else. Then we have the application layer, which only knows the domain layer. So application layer defines the jobs your software has to do, the use cases it has, and the application layer uses domain objects and domain services to perform these tasks. On the top we have the presentation layer, so at some point your user has to see something. This is the responsibility of this layer. It has to present information to the user and interpret the user's commands. There you have your React components that render HTML, and when you interact with your React components in the presentation layer, they call use cases from the application layer. Finally, and it should be the least important layer for you, you have the infrastructure layer. So that's where you have your database, for instance, your third-party services. That's where you want to push back all the complexities coming from external dependencies. So infrastructure layer knows the domain, it knows about your business, but every other layer has nothing to do with the infrastructure layer. So why is it important? Because infrastructure layer, especially in the JavaScript world, is where everything's going to change really fast. Your business is changing, requirements change, but not as fast as, for instance, the libraries you use. So you want to isolate this infrastructure-related code to be able to change it more quickly. So, quick example from our own code base. This is an example of a change we made where we moved from a whole everything mixed up to a more layered architecture. We have this object, opportunity. Opportunity is a really important object in our business at Inato. So that's why I took it. And you can see on the left, it's just a long list of fields. This object is really flat. It's flat because it matches well with the way the data is stored inside the database. So that's why our domain object is flat. And all there is properties, attributes. There's no methods. There's no business logic. All the rules, the business rules associated with these attributes and properties were done inside functions, like the one on the right. So here's our good old change status function, where I mix business logic. If can change status, so this is some kind of business rule. We have a state machine and state machine transitions that are allowed or not allowed. And on the next slide, we have a database query. So at the same time, we're checking business rules and we're performing that database query. This is what Martin Fowler would call an anemic domain model. So that's what we moved away towards the situation we have right now, where on top we have our entity. So this is the same object, the same opportunity object, but we have two major differences with the one we had before. One, this object is much more nested, much more deep. It's not just a long list of fields. We have objects inside objects. So it does not match perfectly the way data is stored, but it matches better the way the product team is discussing business concepts. Second major difference, this entity, this object now holds methods like set status. So all the business rules are encapsulated by the same object, which has properties and methods that act on these properties. We still need to persist changes we make. So for that, we have this interface, opportunity repository. A repository is an interface that allows to fetch data, so find by ID, and store data. So persistence should be discussed with the product team. Persistence is not only a technical concern, but that's why the interface belongs to the domain layer, but the way data is persisted, whether you're using a relational database or a NoSQL data store, that's more a technical thing. That belongs to the infrastructure layer. And generally, your product team does not care. So once you have this, once you've split your domain logic inside entities and your persistence details inside interface implementations, you can write code like this in your application layer. So that's a use case. It's the same feature as before. It's a really simple feature. Change the status of an opportunity. But here, the business logic is encapsulated inside the set status method of the opportunity object. And the database query, the update we had earlier, is encapsulated inside the store method of the repository. So this use case only coordinates my domain object, repository, and opportunity entity. And this use case does not care whether we're using a real database-backed repository or a fake one. For instance, I can test this code by providing an in-memory repository, so an implementation that doesn't use a database. And I think that's really nice. Until now, these examples were mostly back-end related. That's what we're doing on the back-end, but we follow the same layered architecture principles on the front-end side of things. Here's recent examples. We used to have direct calls to analytics spread out throughout the whole code base. So we use Google Analytics, so we had this React GA.pageView inside our components. So if you remember the presentation layer, so our React components, they're responsible for showing information to the user, for interpreting the user's comment, but that should not care which analytics service we're using. So these React GA calls do not belong to the presentation layer. So what we did was we introduced this interface, analytics service, and now my component doesn't know whether we're using Google Analytics or something else. My component only knows that he's got a prop, analytics service, and he calls this prop by logging a page view. So two consequences. The first, I can test my component now by injecting a fake analytics service. I can mock this class and verify that when my component mounts, I'm logging a page view. Second thing, now that my component does not know whether it's using React GA or not, I can change my analytics service. Right now, we are no longer using Google Analytics. We're using something else. And this change only happened in the infrastructure layer, in the implementation of the analytics service. My React components are left untouched. So my opinion makes this code more resilient, more future-proof. So this example concerns is about analytics, but there are a lot of things you shouldn't mix inside your front-end code base. For instance, the way you fetch your data, I think, is not should not concern your components. Your components should just display data. They should not know how data is fetched. For instance, you should not call fetch directly inside your React components. What is fetch is not available if you're doing, for instance, server-side rendering. Your React components should not know how you store data inside your front-end applications. Maybe you're using local storage, but that's not the concern of your React component. What if there's no local storage available in the browser you're using? So previously, when I used to read articles where people were saying like, use this kind of service, factory, dependency injection pattern, blah, 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 I used to think that this was like crap, like overkill, over-engineering. But I've seen that it's not. My claim is that it's not. My claim is that it's worth it. I think it's worth it for all non-trivial projects. So obviously, applying domain-driven design patterns brings a bit of overhead. It's a higher initial cost than when you write more direct code, when you just wire things directly with each other. That's why the blue curve here starts lower. But as soon as your project gets complicated, gets a bit more complex, I think you rip off the benefits. So first, in the long run, you read code more than you write it. So having this ubiquitous language, this shared language between product and engineering, used both in discussions, but more importantly in code, is going to pay off. Second, especially because the JavaScript ecosystem is moving so fast, separating concerns, isolating external dependencies in this infrastructure layer that is pushed back to the edge of your code base, leaves you much more space to deal with your own business complexities. So go ahead, try domain-driven design for yourself, and tell me what you think. Thanks.
Que la famille